and welcome all. Today we are going to see what are the voltage ratings of the transistor and the diode and how we can calculate the value of the capacitor. When the switch is on, the current is flowing through the circuit and a 300 voltage is the voltage across this inductor. The voltage across the secondary will be n times that of 300 volt. N times that of 300 volt means n is the turns ratio. We have already said in the earlier video that the number of turns is 15, 1 by 15th. 1 by 15th of the coil is in the secondary. So the voltage will be n into Vn means 1 by 15th of 300 voltage will be across it when it is conducting. So that is 20 volt will be across this, and this is also a 20 volt. So the voltage across the diode will be 20 volt at this point, and again minus will be here and plus will be here. So the total voltage will be 40 volt of diode we have to select. Now what is the voltage rating of the transistor? When the transistor is off, this is forward bias, this n become plus and this n become minus. So the voltage across this will be output voltage V0, that is 20 volt. So that voltage at this point is 20 volt. That voltage divided by n is the voltage reflected on the primary. So the voltage reflected on the primary is V0, 20 divided by 1 by 15th. This 15 will go to the top, so 20 into 50, that is 300, plus the input voltage. This input voltage plus the reflected voltage will appear across it. So total will be more than 600 voltage of the transistor has to withstand. Now we want to calculate the value of the capacitor. The current we want is 2 ampere, and the time this transistor is on is 5 microsecond. So during the time the capacitor has to provide the current. So 2 ampere of current for 5 microsecond means only 10 microampere of current is needed for the capacitor to supply during this time. Capacitance is equal to Q by V, the charge, by the change in voltage. If 10 milliampere of current is supplied by this capacitor, the output voltage is 20 voltage. So we want only a change of 100 times of 20 ampere, that is 0.2 volt. The change in voltage we want is only 0.2 volt. So if we put these values, Q is 10 microampere and delta V, the change in voltage. The change in voltage in the capacitor is 0.2 volt because of this current flow. So if we calculate, this will be around 50 microfarad capacitor is needed to provide that much of current. This is how we are calculating the value of the capacitor. So these are the voltage rating of the transistor and the diode and the capacitor.